Before life had a name, before worlds spun in ordered paths, before chemistry learned to breathe, there was only the quiet dark, a silence vast enough to swallow time. A stillness so complete that even thought had no meaning, and then a fracture, a whisper of energy, a trembling point of possibility. In that first instant, the universe awakened, not gently but with fire, a cosmic birth cry of heat, expansion, chaos, and light. And from that chaos, stars ignited, stars, the ancient engines of existence, titans of plasma and gravity. They are the makers of light and the makers of life. Yet their gift is not born of peace, it is born of storms. For in the heart of every star lives a truth the cosmos never hides. Creation requires fury. Life begins in fire. To understand how life begins, we must travel to the core of a star, a place where reality itself bends under unimaginable pressure and heat. Here, the temperature reaches a staggering 15 million degrees Celsius. Atoms, the very building blocks of matter, crash into each other with a force beyond our comprehension, fusing together into new forms. Hydrogen, the simplest element, becomes helium, and with every single fusion, light is born. We call this process nuclear fusion. But the universe calls it something else. Alchemy, the oldest art, the forge where everything we know was created. Every atom of carbon in your breath, every fleck of iron in your blood, every bit of calcium in your bones, all of it once lived deep inside a star. Stars do not simply shine, they build. They are the architects of the elements, the cosmic engines that turn simplicity into breathtaking possibility. But the star is not calm. Beneath its glowing skin, powerful magnetic fields twist like coiled dragons. Convection currents churn hotter than molten worlds, bringing superheated plasma to the surface and pulling cooler plasma down. As pressure rises, these magnetic fields tighten and the energy strains against its confines, until the star can hold no more, and then it erupts. A solar flare is not a mere flash of light, it is an explosion of monumental proportions. Imagine 1 billion atomic bombs igniting in the same breath. That is the scale we are talking about. Arcs of fire, larger than our entire planet, are ripped from the star's surface. A torrent of supercharged particles is hurled across light years of space. Following this, a coronal mass ejection can occur, a tidal wave of charged plasma. A storm so vast it can blanket entire worlds, twist magnetic fields, and turn the sky into a canvas of pure electricity. Here on Earth, we once feared these tempests. They can disrupt our satellites, shake our power grids, and interfere with communications. Yet, they also paint our poles with the breathtaking aurora celestial ribbons of green, violet, and crimson dancing in the night sky. But on the cosmic scale, these are just gentle murmurs. Our sun is actually quite serene compared to its smaller, more volatile siblings, the red dwarfs, the flare stars, the ember gods of the galaxy. An astonishing 70% of all stars in our galaxy are red dwarfs. They are slow-burning, incredibly ancient, and dangerously unpredictable. Their rage comes often. Flares erupt from their surfaces daily, sometimes even hourly. For any planet orbiting close to such a star, it would be like living under a sky of constant, violent storms. But to orbit too far is to freeze in the endless cold of space. This creates a cosmic dilemma. For a planet to be warm enough for liquid water, a key ingredient for life as we know it, it must huddle close to its faint, red dwarf star. But in doing so, it places itself directly in the line of fire, exposed to radiation levels that could strip away its atmosphere and sterilize its surface. So, where does that leave the search for life? For decades, we looked for planets like Earth, orbiting stars like our Sun. This seemed logical. We assumed life needed stability. We assumed it needed peace. But the universe is teaching us a new lesson. Perhaps stability is not the only path. Perhaps chaos too can be a cradle for life. Let's return to the solar storm. We see it as destructive, but what if it's also creative? When that wave of charged particles hits a planet's atmosphere, it doesn't just create beautiful auroras. It triggers complex chemical reactions. It can break apart simple molecules like nitrogen and methane, allowing their atoms to recombine into something new, something more complex. Scientists now believe that these stellar storms could be a crucial catalyst, creating the building blocks of life amino acids right there in a planet's atmosphere. The very force we thought was a barrier to life might actually be the spark that ignites it. The fury of the star becomes the forge for biology. This changes everything. Suddenly, the most common stars in the galaxy, these temperamental red dwarfs, are no longer viewed as hostile. They are now seen as potential nurseries for life, teeming with billions of worlds where biology might begin not in a calm, warm pond, but in an atmosphere electrified by a stellar storm. The habitable zone, the region around a star where life could exist, is no longer just a measure of temperature. It's a dynamic, shifting boundary defined by a delicate balance between life-giving warmth and life-threatening radiation. A planet must be far enough to survive the storm, yet close enough to feel its creative spark. Our understanding of the cosmos is expanding. We are learning that the universe is far more intricate and surprising than we ever imagined. Life may not be a fragile accident that occurred in a quiet corner of the galaxy. It might be a resilient, tenacious force born from fire and forged in chaos. From the first flicker of the Big Bang to the raging heart of a flare star, the story of the universe is a story of violent creation. It's a reminder that from the greatest tempests come the greatest possibilities. And as we continue to gaze out into the quiet dark, we are no longer just looking for reflections of ourselves. We are looking for the children of the storm. We are just beginning to decipher this epic story written in the stars. Every new discovery, every new telescope, brings us closer to understanding our own origins and our place in this vast, fiery cosmos. The answers are out there, waiting in the light of a billion distant suns. Imagine a world, balanced on the knife's edge of existence. Close enough to its star to feel warmth, to harbor hope, but so close it's constantly besieged by stellar fire. It seems like the absolute worst place for life to take root. But what if I told you that in the grand, strange story of the cosmos, nature has a twist? What if the very storms that threaten to destroy life are the same forces that ignite it? Let's journey together, not to a familiar past on Earth, but to a distant, alien world. Picture this, a young planet orbiting a volatile red dwarf star. Its years a blur, passing in just a handful of our days. Oceans, vast and turbulent, churn beneath a thick, steamy sky. Volcanoes bleed sulfur into the atmosphere, painting the clouds with a chemical haze. And through this haze, lightning cracks, its tendrils branching through the sky like the roots of some celestial tree. Winds, unimpeded by forests or mountains, scream across endless plains of black basalt. And look up. Above it all, shimmering curtains of light stretch from one horizon to the other. These aren't just polar aurors. They are a global phenomenon, a planet-wide show, pulsing with the raw energy of constant stellar storms. This world is fierce, it's unforgiving, it's utterly, magnificently wild. But nature isn't afraid of a little violence. In fact, nature thrives on it. It harnesses it. High above, in the upper atmosphere, the real magic begins. A solar flare erupts from the red dwarf, sending a wave of high-energy particles slamming into the planet's magnetic shield. Some get through. These particles crash into simple molecules like nitrogen and carbon dioxide. Bonds break, atoms rearrange. Suddenly, nitrogen, which was inert, becomes nitrates, a vital fertilizer for life. Carbon atoms, energized by the chaos, begin linking up, forming the long, complex chains that will become amino acids, the very seeds of proteins. The storm isn't just a light show. It's a cosmic factory forging the building blocks of life from thin air. Down below, the storm continues. A lightning bolt carrying 1 billion volts of electricity strikes the surface of a primordial ocean. The immense energy doesn't just dissipate. It supercharges the chemical soup. The storms churn the oceans like a cosmic blender, mixing ingredients, forcing reactions that would never happen in calmer waters. At the same time, deep on the ocean floor, hydrothermal vents gush superheated, mineral-rich water. This isn't just hot water. It's a chemical cocktail, bubbling life's first ingredients up from the planet's core. You might be thinking this sounds like science fiction, but it's actually laboratory fact. Back in the 1950s, the famous Miller-Urey experiment simulated the conditions of early Earth. Scientists took a sterile flask filled with simple gases, methane, ammonia, water vapor, and zapped it with electrical sparks to mimic lightning. What they found was astounding. Within just a week, the clear water had turned a murky brown. And in that brown soup were amino acids, the fundamental components of proteins. They proved a foundational truth of the universe. Energy births complexity. Chaos writes the score for possibility. The very storms that seem so destructive are actually carving the pathways toward biology. And so, somewhere in a quiet tide pool on this alien world, sheltered for a moment from the raging winds, a miracle occurs. Beneath the eerie glow of the constant aurors, a fragile chain of molecules, forged in the heart of the storm, stumbles upon a secret. A secret so profound it will change the fate of this planet and perhaps the universe itself. It learns how to copy itself. Self-replication, it's the first tentative spark of what we call life. This molecule doesn't breathe. It doesn't think. It doesn't move with purpose. But it does one thing that separates it from every rock and grain of sand around it. It persists. And in the great cosmic story, persistence is the very first definition of being alive. Think about what life truly requires. It boils down to three sacred gifts from the universe. First, you need the ingredients, the basic stuff. Carbon, hydrogen, oxygen, nitrogen, the Lego bricks of biology. Our storm-battered world is rich with them. Second, you need structure. You can't build a house with just bricks, you need blueprints. In biology, this means complex molecules like amino acids to build proteins and lipids to form membranes. The constant energy from the star and its storms is the architect, forcing simple ingredients to assemble into these more complex structures. And third, the most crucial gift of all, you need energy. A spark, a force to rearrange matter into meaning. The calm, peaceful pond is a beautiful image, but it's a dead end chemically. It's the chaos, the disequilibrium that drives creation. And on our world, the stellar storms deliver all three gifts in abundance. Cosmic rays from deep space, channeled by the planet's magnetic field, act as chemical matchmakers, creating bridges between atoms. The star's harsh ultraviolet light, which would scorch unprotected life, is perfect for forming sugars and nucleotides, the components of RNA and DNA. The lightning we saw continues to assemble amino acids in the seas. The hydrothermal vents, those deep-sea furnaces, provide the perfect environment for metabolism's first faltering reactions. Even the minerals in the clay on the seafloor play a role, acting as templates that help shape the earliest cell-like bubbles, fragile membranes of fat, separating a tiny ordered inside from the chaotic outside, a miracle of structure. The lesson here is profound. Life is not born in calm, tranquil seas. It is forged where forces collide. It rises from the heat, the pressure, the electrical discharge, where imbalance fuels relentless change. This isn't just a happy accident. You could almost call it chemical destiny. The universe seems to be hardwired to build complexity, to experiment with existence, whenever and wherever conditions permit. Planets bathed in the fury of their stars aren't cosmic death traps. They are laboratories. They are crucibles of creation. Think about the beginning of our own universe. It wasn't born in quiet serenity. It began with the most violent event imaginable, the Big Bang, an explosion of unimaginable force and energy, and life, it seems, follows that same fundamental law. Order does not spring from tranquility. Order grows from chaos. Life emerges from the storm. Now, let time pass. Not in years or even centuries, but in epochs. Millions upon millions of years go by on this world. The simple, self-copying molecules evolve. They become more efficient, more stable. They group together inside those mineral-forged bubbles, creating protocells. The membranes thicken, becoming better at protecting the precious machinery inside. Inside these tiny sanctuaries, a new molecule, RNA, begins to take on a critical role. It starts to store information, a memory of what works. Reactions that were once random and chaotic begin to organize into networks, pathways. This is the dawn of metabolism, the ability to take in energy from the environment and use it for growth and replication. The storm is no longer just outside. Its energy has been brought inside, tamed, and put to work. From the relentless fury of a red dwarf's tantrums, a new force has emerged on this planet. It's quiet, it's microscopic, but it's tenacious. It's the force of life, born of starlight and storm, now ready to begin its own journey, to face the chaos of its world and step by tiny step, to conquer it. The storm gave it birth. Now it must learn to survive it. We once believed life needed calm oceans, mild sunlight, and quiet skies, a gentle cradle for a fragile beginning. But the story of our own Earth tells a different tale, a story written in fire and forged in chaos. 4 billion years ago, this planet was anything but calm. Our skies cracked with relentless lightning. Volcanoes choked the air with sulfur and ash. Lethal radiation from a young, angry sun bathed the seas. And yet, it was precisely in this violent, primordial crucible that life emerged. The oldest fossils we've ever found aren't in some serene, shallow lagoon. They lie near hydrothermal vents, deep on the ocean floor, places where superheated, mineral-rich water erupts from the planet's molten heart. It's a place of extreme pressure and temperature, where chemistry and heat collide in a furious dance. Even today, we see life's incredible tenacity in what we call extremophiles. These are organisms that don't just survive, but thrive in the most hostile places imaginable. Boiling hot springs, pools of corrosive acid, bone-dry frozen deserts, and even inside the cooling water of nuclear reactors. Life doesn't fear the extreme, life is born from it. The more we explore the boundaries of life on our own world, the clearer a universal pattern becomes. Where there is a source of energy, whether from a star or a planet's core, where there is a rich soup of chemistry, the basic building blocks of matter, and where there is enough time for nature's grand experiment to unfold, life tries. Life begins, life persists. It's an almost cosmic imperative, a fundamental property of the universe itself. Now, humanity stands at the edge of its first great cosmic horizon. For the first time, we are peering beyond our solar system, not with guesswork, but with powerful telescopes that turn faint points of light into worlds. We are finding planets everywhere we look, thousands of them. Rocky worlds like our own, vast ocean worlds, volcanic planets covered in seas of lava and frozen ice giants. Some of these exoplanets orbit violent, flaring suns. Their skies are likely ablaze with spectacular world-spanning auroras. Their surfaces are constantly being sculpted by storms that would make our most powerful hurricanes look like a gentle breeze. Not long ago, we would have looked at such a world and seen only danger, a place hostile to any form of life. But our perspective is changing. Now we see potential. We see possibilities. We now look at worlds bathed in stellar fire and wonder what might be stirring beneath their storm-lit seas. We see planets with thick atmospheres and imagine life forms that might ride their turbulent winds. Our telescopes are sharpening their gaze, their mirrors growing larger, their resolution more precise. Our spectroscopes are learning to sniff the atmospheres of these distant worlds, searching for the telltale chemical fingerprints of biological activity. We are building robotic explorers designed to ride solar sails, pushed by the light of stars across the interstellar winds to visit these new frontiers. And soon, perhaps very soon, in the grand scheme of things, we may look upon the light from a distant world and see it. The definitive evidence, the fingerprints of life in its air, a hint of oxygen that shouldn't be there, a trace of methane that points to metabolism, a delicate chemical imbalance that whispers across the light years, we are not alone. When you truly analyze it, life is not some bizarre cosmic accident, a 1 in a trillion shot that happened only here. It begins to look more like a cosmic consequence, an inevitable outcome of the laws of physics and chemistry playing out on a planetary scale. Where stars shine and provide energy, where storms rage and mix the elements, where oceans stir and molecules dream of complexity, life finds a way to rise. We often feel separate from the universe, as if we are observers looking in from the outside. But that's an illusion. We are its direct expression. We are its grandest experiment, the part of its story that has become conscious of itself. Think about it. Every single atom in your body, from the calcium in your bones to the iron in your blood, was forged in the heart of a star that lived and died billions of years ago. Every breath you take is composed of ancient starlight, cooled and transformed into air. Every beat of your heart echoes the rhythm of cosmic cycles older than our own galaxy. In a very real sense, we are the universe's memory. We are the storm's descendants. We are the children of fire. And this means that somewhere out there, across the unfathomable oceans of stars, other fires burn. Other storms rage. Other worlds are breathing their first breath under alien skies. The cosmos is vast, but life is resilient. Creation is inevitable. So, the next time you look up at the night sky, don't just see a random scattering of distant lights. You're not just looking at stars. You are looking at your origins. You are looking at the engines of existence, the great cosmic furnaces that carved you and everything you see from the void and the fabric of time. Life did not begin asterisk despite asterisk the storms and the fire. Life began asterisk because asterisk of them. And in the endless silent dark between the galaxies, a fundamental truth burns bright and clear. Where there is fire, there is potential. Where there is storm, there is creation. Where there is energy, life waits to awaken. We are born of starlight, and one day, in some distant future, our atoms will return to it. But until then, we have this incredible gift. We can look up, we can learn. We can wonder who else is out there, watching the same stars, born from the same fire, searching for the same meaning. The universe is not silent. It speaks. It speaks through the language of atoms, through the roar of storms, and through us. And its first, most profound lesson, echoed across all of eternity, is beautifully simple. Life is brave. Existence is a miracle. Life begins in fire. It grows through storm. It rises from chaos. It endures through time. And somewhere, right now, beneath a sky lit by strange and beautiful alien auroras, in a chemical-rich ocean waiting for a spark, life stirs again, not as a myth, not as a miracle, but as the universe simply fulfilling its own magnificent nature. Storms do not only destroy, they build. Thank you so much for watching. If this journey through the cosmos sparked your curiosity, please consider liking this video and subscribing to the channel for more explorations into the wonders of our universe. We're just getting started.